You might feel that we've now solved the problem, but in fact there are still two difficulties to overcome. The first is that what we found is the point on the average cost curve where the rate of change of average cost is 0, but that might not be a minimum point, it might be a maximum point. So we've still got to do a little bit of calculus to work out and check that we really have found minimum average cost. The second problem is that we've come up with an answer which is not a whole number. Since the builder can't possibly build a fraction of a number of floors, we have to determine which is the whole number of floors that minimises unit costs. We have two difficulties to overcome. First, we need to be sure that our answer is a minimum, not a maximum value. And we can deal with this problem by differentiating a second time. The answer we got by differentiating the original function is itself a function that we can differentiate. So the second order derivative is the derivative of the first derivative. Now the first derivative is minus 100,000 x to the minus 2 plus 500. So d2 ac by dx squared equals minus 2 by minus 100,000 x to the minus 3, which equals 200,000 over x cubed. Now in our case, x equals 14.14. So here we have 200,000 over 2827.15, which gives us 70.74. So the second order derivative is positive. So we know that x equals 14.14 is a minimum, not a maximum value. But we have a second problem to overcome. Since our answer is only just over 14 floors, and we clearly have to build a complete number of floors, we have to decide whether to build 14 or 15 floors. Now we'd expect the answer to be 14, but we need to check we're not dealing with straight lines here. So we'll establish the average cost of building 14 floors, and then establish the average cost if we build 15 floors, and then we can see which is the lower unit cost. Now our average cost function is 100,000 over x plus 40,000 plus 500x. So the costs if we choose to build 14 floors would be as follows. Average costs will be 100,000 over 14 plus 40,000 plus 500 times 14, which equals 7,143 plus 40,000 plus 7,000, which comes to 54,143 euros, the average cost of building 14 floors. Now let's see what happens if we choose 15 floors. Average costs are now 100,000 over 15 plus 40,000 plus 500 times 15, which gives us 6,667 plus 40,000 plus 7,500, which comes to 54,167 euros. So it's going to be a slightly higher unit cost if we choose 15 floors. So by using a second order derivative, we've confirmed that we really do have a minimum average cost with 14.14 floors. And with some simple calculations, we've been able to show that the whole number of floors which will minimize average costs is 14.